Okay, so part 4, appendix. Okay, so in the beginning of the codebook, it mentions combined building drains, and it says can't be installed. What this one basically talks about is in certain situations, certain municipalities, yeah, it might be considered okay to do that, to install them. That's why we have to go through and learn about them, right? Also, questions you might see are going to have to do with combined building drains. Now, I talked about it before with the tables. You have to know how to use them backwards and forwards. If they give you a size, fixture unit load, you have to know the grade, or you have to be able to figure it out, and vice versa. Now, it says right here, these notes are included for explanatory purposes only, do not form part of the requirements. The number that introduces each note corresponds to the applicable requirement in this part. So yes, it is for explanation, but being one of the people who actually writes these exams and is part of the committees that do that, we take them off the pictures because you guys never look at them, right? And it's a one-stop shop. So like, give you an example off this first drawing, there is 4 potential red seal questions you might get off of it. The first one with the first picture is, can I feed an auxiliary building with the same services on the same property? So that could be a garage, could be a coach home. Yeah, that's allowed right here. Can I feed a duplex or a townhouse with separate services? Yep, that's allowed too. Can I feed them with the same services? Yep, that's allowed, as long as there's independent shutoffs in both portions, or in all the portions. So yeah, that's allowed. And then the last question is going to be, can I feed an adjacent property with the same services? And the answer is no. Reason for that is because, again, you have to remember that no one knows what you're doing on your property, right? Seismic restraints. So a lot of you guys don't have to deal with seismic across the country. But in places like BC, we're going to have seismic restraints that we have to put on hot water tanks and things like that, or even on the piping, right? And it's usually done by one of 2 ways on the piping. Either it's going to be a riser clamp with 1-inch pipe at a 45-degree angle going up to the ceiling, or it's going to be with aircraft cable. It's your other option. This picture here, a couple of questions that you might get. How many shower heads can be served by 1 shower drain? Well, even though this says not permitted, you can count them 6, right? If we look at this one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many shower drains do we need? 2. Okay, so every 6 needs a drain. Now, the reason why we talked about this before, they don't want it sloping off to one central drain, typically, and that's because no one wants your foot fungus, right? No one wants anything that might be on your body to touch them, right? It's not sanitary to do that. Another question you might get on this is, what is the minimum distance between shower heads? Right here, 750, right? Okay, concealed overflows. The use of a concealed overflow does not preclude the use of a standing waste. So a standing waste is basically a floor drain that comes out of the floor, usually for like a clawfoot tub or a Roman tub. And let me see if I can just find a picture that's a good one. No, I can't. So I'll have to leave that for now. Oh, maybe. Here we go. Okay, so this isn't a very good picture, but you'll get the idea. So this is what a standing waste is. So you can see here that we have an overflow in part of this tube, right? And if we want, we can pull up on this knob to activate it, right? Another image of what it might look like is something like that. So that's what it is. It typically comes out of the floor. That's your standing waste. Okay, this picture here, A22311 and 3. So a couple of questions you might get from this is, where are we allowed to use slip joints? Well, we're allowed to use it to connect the tailpiece. We're also allowed to use it right here on the outlet after the P-trap. But we're not allowed to use gasketed unions here. We are allowed to use them here. You might get a question, how is the trap seal depth measured from where to where? So that would be from the trap dip to the trap wear. Okay, so right here, so this is the wear, and this is the dip. Next, okay, prohibited traps. So except for an S-trap standard, S-traps are prohibited by Code Clause 25631B, which limits the fall in the fixture drains. Crown vented traps shown in that figure are prohibited by Clause 25631A, which requires that the distance from the trap wear to the vent be not less than twice the size of the fixture drain. So we all know that's code. Now, a trap, okay, the two trap standards we talked about before. We have the P-trap standard, which is for janitor sinks, and then we have an S-trap standard, which is a toilet, is essentially what that is. Okay, when you guys are dealing with septic, this, even though this is a bell trap, what it is similar to is called a bell and siphon, and that would be for a gravity septic system. It would have something similar inside of this septic tank, so that would be allowed. Okay, grease interceptors, T-fittings. Now this one's pretty simple, straightforward. When can we use T's? To join vent pipes, right? But they have to be installed in this orientation, not these ones. And then same thing with Sani T's. Where can we use them? This says these are not prohibited. It says use a Y and 1/8 bend. So just a reminder, the 1/8 bend is a 45-degree fitting. And it says up here, a sanitary T-fitting may be used to change the direction of flow in a drainage system from horizontal to vertical, but may not be used to change the direction of flow in a nominally horizontal drainage system. So that might be important also. This guy, your permitted, not permitted table. You will get probably quite a few questions on this. Now, again, depending on the edition of codebook you have, if you have a 2015 first edition, you're going to have asbestos cement pipe on this table, and you're going to have multiple references to asbestos. Don't worry about it. They can't test you on that anymore, okay? Because it's not in the 2020. You're going to have a question on this. Polyethylene water pipe and tubing. Series 160 size with compression fittings. Okay. So where are we allowed to use it? Underground, under a building, and outside of a building. So you see these little notes here, these numbers? Make sure that when you're going through this, you come down to here and you read what it says. So permitted only for water service pipe. So that Series 160, we've talked about it before, only for water service. PVC, okay, we've talked about SDR numbers before. So you guys, if you remember, SDR refers to, it's called standard dimension ratio, and it refers to the outside diameter divided by the wall thickness. And off of tables, that can give you a standard pressure rating of that pipe. Now, again, with pipes with the same SDR, they're going to have the same pressure rating on both of those. Right. Yeah, so always look at these little numbers. And if you come across a question like this where you have to use this permitted, not permitted table, make sure you check out the code clauses that are in here also. Okay, copper tubes on here, right? So you're definitely going to see a question on types of pipe that are allowed to be used in different places. So if it said, okay, what type of copper can I use in a potable water system above ground? Let's start with that. So the potable water system above ground is right here. So I can use KNL hard, KNL soft, and M hard temper for above ground potable water. Now, remember that potable water is KNL. If we're dealing with hydronic heating, it's going to be M. And DWV would just be used for drainage systems, venting systems, or condensate drains from air conditioners. We've used it for that too. So yeah. Now, remember down here, we always have these references throughout the code book, and I mentioned it a couple times. It says permitted only residential buildings containing 1 or 2 dwelling units and row houses that do not exceed 3 stories in height. So single family homes, duplexes, townhomes. There's multiple mentions in the code book about that. Okay. All right, concrete pipe. No, we don't care about that. This one here, A22551, polyethylene pipe used underground. So joints within high density polyethylene pipe, HDPE. So that's the same thing as polyethylene. It's just high density polyethylene. Shall be heat fused according to manufacturer's instructions. Joints between high density polyethylene pipes and other materials shall be made with a suitable hubless coupling. There's 2 questions right there. How is a joint HDPE? It's heat fused with what? An iron, right? Hubless coupling. Yeah, we can join it that way too. Okay. Solvent cement. Often this shows up. Might ask you the color code. Might ask you the color for transition solvent cement, let's say. So let's see where that is. So PVC is gray, ABS is yellow, CPVC is clear, and transition is white. So if we're remembering what types of pipes we use with transition cement, it's ABS and PVC. Okay. This guy we don't really care too much about. Nope. Nope. Galvanized steel pipe. So this is similar to the combined building drains idea. So it says the use of galvanized steel pipe and fittings in a water distribution system may have been proven acceptable on the basis of past performance in some localities, and its acceptance under the code may be warranted. So again, depending on where you are, if you're in the middle of nowhere, right, maybe it's allowed. Same thing with saddle hubs and fittings. So even though the code says that we're not allowed to put those in, it may be acceptable in different places. Okay, flow restrictors on shower heads. Some of you guys take them out just so you get beaten up by the shower every time you have one, right? What this is saying, so you got to remember where this is in the code book. It says flow restriction devices within supply fittings should not be removed. Again, it's not saying shall not, it's saying should not. Okay. Examples of water shut-off devices include occupant sensors and self-closing valves. So these are going to be for public facilities, and it's going to be your infrared sensors or your push-button timed valves. Okay. All right. Something that's different in the 2020 versus the 2015s is, remember the 5 temperatures that we need. So it's 49, 60, 75, 99, and 540 from the code book. Now, 60 is your hot water heater set temperature. Okay. Now we know that the maximum temperature discharging to a bathtub is 49 degrees. What they did in the 2020 was they added this, making it 43 degrees in healthcare facilities or seniors residences. So again, they won't ask you about this, but this is just good to know for installation in the field, right? That it can only be set at 43. Reason why people who are sick might be more susceptible to heat. Old people have typically thinner skin, so they could probably burn a little bit easier. So that's a new requirement of the 2020. Air admittance valves, do we need here? With air admittance valves, this is an important point. So material of the diaphragm can be damaged by exposure to acidic or corrosive fumes in ambient atmospheres. Therefore, air admittance valves should only be installed in locations where there's a potential for exposure to such fumes. So that might be a question. Where can I not install them? Well, anything that has an acidic or corrosive fumes. Okay. This one's fun. All right. So you're going to have a coefficient of pipe expansion question. Everyone does. It's on all exams every single time. Okay. Now, if they don't give you a coefficient, what you want to use is you want to use this drawing. And this drawing isn't really that complicated to understand. I'll show you. So most likely they're going to talk to you about using ABS. But what we can do is, let's say the question says I've got 100 meters of, let's say, ABS pipe. Install temperature is 10 degrees Celsius, and it's run at 40, whatever it is. Okay, so the first thing we do is we figure out the temperature difference, the delta T. So 40 minus 10 is going to be 30 degrees Celsius. So that puts us here. Okay. Now, ABS is that line right there. So all you got to do is come up to the point where it intersects that line at 30 degrees. Okay. And then just draw a line all the way over. That's not very good. Try that again. That's better. Okay. So it's more of a guess with this, but you can see here that this would be the 30 millimeters. So we're just slightly under that. I'd say probably 26, 27. Right around there. Okay. Now with this table too, we have to remember that it's only per 10 meters of pipe. So what you have to do is you got to go 100 meters divided by 10 meters equals 10, and take that and multiply that by 27 millimeters. And then you get to 70 millimeters as your total expansion. That's it. Easy. You might get an even simpler question, which says, which type of pipe would increase or expand more than the other at the same temperature? So let's say it said, I don't know. Let's go copper and ABS. Which one's going to expand more? Well, it's going to be the ABS because copper is lower on this graph. So hopefully that works for you guys. Yeah, that's all you got to do. Very easy. If you need an example, right here. Okay, A23391, expansion and contraction. So expansion and contraction in piping systems may be accommodated in a number of ways, including but not limited to piping design and layout, material selection, and the inclusion of expansion joints. That might be a question you guys get. How can we do it? So expansion loops, expansion joints, different things you can do. Air brake, if you guys ever need a visual, it is right here. So same size as the indirectly connected pipe, but can be no less than 25 millimeters or 1 inch. Okay, and remember, if it's an air brake, that's typically for runoff or sewage, whereas a gap is for a faucet. That's why it's like gap tap, right? Okay, this one, a couple of questions come from here. So what can we use underneath hub and spigot pipe installed underground? Well, we can use sand, crushed rock, or firm earth. Okay, that's the first picture. We can have a layer of concrete with bell holes, just like we can with firm earth, as long as we have bell holes. Or we can have a concrete encasement with engineered supports. So I believe that's the answer to one of the questions if you guys see it. What's not allowed? Piers, planking, and obviously a big boulder. I mean, no kidding, right? Okay, backfilling pipe. in a trench. Now, there's a couple of questions you might get off of this. So the first thing it says is stronger pipes may be required in deep fill or under driveways, parking lots, etc., and compaction for the full depth of the trench may be necessary. But when we're dealing with the minimum, what it is it's 300 millimeters above the pipe. Now, this pipe could be installed 8 feet underground, 10 feet underground, I don't know, 20 feet underground. It really doesn't matter. But what it's saying is we need to tamp down at least 12 inches of firm earth above it. Okay, we don't need that. This one here, A23651, air pressure test. So the addition of a non-toxic indicating substance such as an aerosol, fluorescent dye, smoke, or other odorant to an air pressure test may help identifying location of the leak. So I've actually done that. And because it does mention it in the book here, that's a more than fine answer. What can you do if you're looking for a leak on an air test? So what we've done is sometimes we've done perfume. Sometimes we've done air freshener. We just spray it down the pipe and then pressurize it with air. And then whichever room smells like perfume or aerosol, that's where your leak is. Okay. This is a good point. Pressure testing potable water systems. So the plastic piping manufacturer should be consulted to determine the appropriateness of using air pressure test in the piping system. So what they're talking about is things like CPVC. If you guys use CPVC, you should definitely check if your boss wants you to throw on an air test. Check with the manufacturer, see if it's okay. Because what can happen is if you have weak piping, it can actually create a lot of shrapnel if it blows out. And obviously that's not a good thing. Okay. This one, there are several questions you're going to see on the exam. All right. How is a food display connected to a sanitary building drain? Well, it's trapped and indirectly connected through a trapped floor drain. Right from the picture. What do we need to have on it? We need to have a clean out on the upstream side, right from the picture. Down here, we have a grease interceptor from a 3-compartment sink. So how is it piped? Well, it has a vent, and it is piped directly. Oh, look at that, to the sanitary building drain. But what isn't is glass filler, ice cream scoops, coffee drips, and fridge and food compartments. Those have to be trapped and indirectly connected through a trapped floor drain. So there's a couple more questions for you. This one here, this says discharge from a relief valve. So relief valves are typically on water heating devices, hot water tanks, boilers, things like that. So this is specifically talking about that, and where you're going to see it is in the hydronics section, most likely. It's going to say, what is the maximum height that the pipe can be from the floor drain? Well, 300 millimeters, 12 inches. What's the minimum? 1 inch, because it's an indirectly connected pipe forming an air break. Okay, so that's from the discharge piping from heating devices. Minimum 1, maximum 12. This guy here, how are clear water waste connected? Well, indirectly to a floor drain with possibly installing a backwater valve because this is a storm system, all right? Now, if we have drinking fountains installed on 3 or more stories, we have to extend the vent all the way to outside air. So that might be a question you guys see. Down here, trap for leaders, serves receptacles draining indirect connection. Okay, so we have to have a building trap on a storm system that drains indirectly connected fixtures. Right from the picture. That's a good one. Okay, this guy, sanitary drainage pipe connections. So this is a soil array stack. And what it's saying is we're going from vertical to horizontal. So this picture is showing us that there can be no sanitary drainage pipe connections within 1.5 meters of that change. Okay, whether it's going vertical to horizontal or whether it's offsetting and then going vertical again. So that's a minimum. This guy, you are going to get a suds pressure zone question, guaranteed. What I would do is I would match it to whichever portion of this picture it aligns with, and then get your answers from there. Now, remember this, it says 40 times the stack nominal pipe size, or 2.44 meters, whichever is less. So if we do some math on that, let's say I have a 3-inch times 40, gets me 120 inches. And 12 divided by 3.281. So now, if it's a 3-inch pipe and it's saying 40 times the nominal stack size, so I use 3-inch. So it's giving me a minimum suds pressure zone dimension of 3.05 meters. But what this question says, or what this is showing us here, is I don't need to go more than 2.44. Right? So even though my math says it's 3, I don't have to go above 2.44 on that guy. Yeah, so suds pressure zones compared to the picture, figure it out that way. Anything else in here? No, I think we're good there. Okay, this is often a question. Waste with organic solids. Equipment such as garbage grinders and potato peelers produce waste with organic solids. These devices reduce most waste into small sized particles, which will flow easily through a drainage system. However, if they're located upstream of an interceptor, the particles could block the interceptor, because we know that there is a fitting inside that reduces the opening in an interceptor. So that's what they're saying. And the question will specifically mention potato peelers. It's going to say that. So what do we need to install? We need to install an organics waste interceptor before a grease interceptor. Okay. This one here, this is just basically saying that anytime you guys cook bacon, make sure you dump it down the drain. No? Okay, you guys are having fun. All right. What else we got? Trapping sinks. Okay. So what is the developed length? What is it measured from? Right there to there, there to there, there to there. What is it? 1,200 millimeters. That's going to be a question. So remember, a fixture outlet pipe is another word for a tailpiece, if you want to use the slang. And then this might be your next question on this picture. If it's a 3 compartment, the trap has to be 1 size larger. 2, it can be the same size. There goes a couple questions off that picture. This picture. Okay, so you're going to get a question on one of these. These are running traps. Okay, so the first one deals with lab sinks and washing machines, and the second one is floor drains and shower drains. So it's going to be either or. It's called a running trap. So what do we need on it? On both of them, we need to have a clean out installed downstream, and it needs to be vented. Now, when we're dealing with lab sinks and washing machines, we have to have a clean out on the upstream side also. So another question you might get is, what does not need to be left indirectly connected while servicing the fixture? And your options are going to be a food display case, a fridge, or something like that, a laundry machine, right? So the answer is going to be a laundry machine. Doesn't need to be left indirectly connected. Reason why, we can just pull that little hose out. No big deal. Everything else would be hard piped. Okay. Properly trapped and vented. Okay, so this is important too. It says where an interceptor other than an oil interceptor serves a group of fixtures requiring more than one trap, each fixture must be properly trapped and vented. And then it says see Article 2552 for venting oil interceptors. So we may have to vent oil interceptors, but if you get a question, what needs to be installed downstream of an oil interceptor, it's a cleanout, not a vent. Now remember, we can use interceptors as traps as long as we have a minimum trap seal depth of 38 millimeters. A couple questions come off of that guy. Okay, 24521, untrapped leaders. So when an untrapped leader drains to a combined building sewer, clearance requirements are the same as for vent terminals. So I think we're going to see the vent terminals coming up. But yeah, just remember that. So an untrapped leader, if you ever get that question, make sure you check the back of the book. Subsoil drainage systems. What do we need from this guy? Nothing, not really, except that it does say, it says when we have connections to sanitary drainage systems or a trapped sump, they may require backwater valves. Now you have to remember too that we never have normally closed backwater valves because that doesn't allow for free air circulation in the drainage and venting system. So it's always normally open. Okay, you're gonna get a couple questions off this guy. All right, so what size is the fresh air inlet for a building drain? 4-inch, right there. Easy. What do we need? We also need to clean out on the building trap, which is right here. Between the vent and the building trap, how far is it away? Not more than 1.2 meters, right there. Where is the building drain cleanout located? And it says the answer is going to be as short as possible to the place where the building drain leaves the building. Okay, so this distance as short as possible for this guy or this guy. All right. Now, where else can we install a building trap? Outside in a manhole. But it has to be accessible, and we have to have a fresh air inlet. Okay. Maintaining trap seals. Periodic manual replenishment of the water in a trap is considered to be an equally effective means of maintaining the trap seal in floor drains in residences. This is a key statement. So, you might get a question. Do we need to install a trap primer in residential or a floor drain? Answer is no. What you can do is you can instruct the homeowners to every month dump a liter of water down in the floor drain, and that's considered an equally effective means of maintaining that trap seal. Okay. This one, so yes, you can connect it to a toilet, you know, flush valve, flush tank. You can have an indirect clear water waste connection, that's fine. With a trap primer, it's going to be on a cold water pipe. And we also want to have a back siphonage preventer. So we need to definitely find the picture. Okay, arrangement of piping at a sump. All right. So this one, there's always a question. Guaranteed you guys can get a question on this. It says in most installations, controls will be installed in conjunction with a float to automatically empty the sump. If such controls are not provided, the capacity of the sump should equal the maximum inflow to the sump that's expected to occur in any 24-hour period. So if we have to manually turn that thing on, it needs to be a maintenance guy that comes in once a day, kind of idea. Now, another question you guys are going to see is about these floats. It's going to say it's either going to be the third or the fourth float in a sump. What is it for? And what it's for is your high-level alarm. Okay. The first two are your normal operating. Sometimes if there's a 4 floats in a sump, the third one is just a backup or an optional, right? But the question is going to be, what is the third float in a sump for? And that's your high-level alarm. Now, the next question you're going to get on this, what valves or what fittings or valves are installed on the discharge side of a sump? Union, check, shut off, or union, backwater, shut off in the direction of flow. That's what the arrow indicates. Now, these have to be approved pressure pipe and fittings. So when we go back to, I believe it's in section 2.2, where they're talking about sewage sumps and force mains and things like that. That's what they're saying with the pressure requirements, is that piece of pipe right there. Now, this point right here, it says watertight and airtight cover to be provided if the sump receives sewage. One of the questions you might get is, let's say we have a sump installed in a parkade on the 4th level. What do I need to make sure I have? And it didn't indicate in the question whether it was receiving sewage. It could be a storm sump, right? So it does not need a water or airtight cover unless it specifically mentions sewage. All right. And then number 1, see Article 2577 for sizing the required vent if the sump receives sewage. Yeah, great. So yeah, there's going to be a couple questions on this picture. All right. A24643, protection from backflow caused by surcharge. The requirements in the sentence 24643 is intended to apply when, in the opinion of the authority having jurisdiction, there's a danger of backup from the public sewer. Now, this is a 2020. I think if you guys look in the same picture, if you have a 2015, it's going to also say that you can use gate valves on the fixture outlets instead of backwater valves. So just remember that. I think it also mentions it in here too. Okay, this point here, so subsoil drains connected to the upstream side of a trapped backwater valve or a separate trap and backwater valve. And then we just look at these sentences to figure out what it's talking about. So what can be installed on an individual fixture? Well, backwater valves, right? What can be installed on the drain itself? Backwater valves, okay, right off the picture. Cleanouts. Okay, so to accommodate the limitations of sewer cleaning equipment, the cleanout should be located as close to possible to the exterior wall of the building, either inside or outside, and be accessible for sewer cleaning equipment. So typically what I've seen, I don't know if you guys have, but typically what I've seen is when they're running the stacks, even if they're on interior walls, they're usually close to the exterior walls. I don't know why that would be a big thing, but this one's saying it should be at least acknowledged. Okay, food receptacles, what do we have? Clean out upstream in direct connection with an air break to a floor drain to the sanitary drainage system that is vented. Cool. This one, cleanouts for fixture drain. So a trap cleanout plug cannot be used as a cleanout for a fixture drain. So that's why we have to install a separate cleanout or have a union P trap. But again, when we're dealing with union P traps, they can't be buried, right? They have to be accessible. A24811, minimum slope. So it says, although slopes below 1 in 100 are permitted for pipes over 4, they should only be used where necessary. Steeper slopes and higher velocities will keep the pipes clean by moving heavier solids that might tend to clog the pipes. So this just goes back to, we remember the tables where 3 inch and under has a minimum slope of 1 in 50 or 1/4 inch per foot, and 4 and above, minimum slope 1 in 100. Any kind of island fixture question, if you get, I haven't heard of any lately, but if you get them, here's the picture, match it to the picture. Try and do your best to figure it out. Okay, hydraulic loads for laundry traps and floor drains. When determining the hydraulic load on a pipe, no allowance need be made for a load from a domestic clothes washer when discharged to a laundry tray, since the hydraulic load from the laundry tray is sufficient. Also, no hydraulic load is required from a floor drain in a washroom, since it's for emergency use only. So if we have, sometimes it's kind of weird, but if we have the clothes washer discharging into this guy, that's on this guy before the P-trap, that's when it's saying we don't need to account for the clothes washer. But in this case, we do. All right. You're going to get a question on this. What is the minimum length of standpipe? 600 millimeters, 18 inches. Okay. Okay, that one. All right. Pipe sizing, DWV. Your directions for doing so. So these are your rainwater drawings. Okay. Sanitary, branches, stacks, building drains, building sewers. Determine the load in fixture units from all fixtures except continuous flow, right? So we do everything except a continuous flow. We need the liters per second for the continuous flow, multiply it by 31.7 to obtain the number of fixture units. Add the loads, use these tables. So that's sanitary pipes. Then we have storm pipes and combined pipes. Now, just remember, whenever you're doing any of these, you're probably not going to get a picture. It might just be a simple question. It might just say, okay, how many fixture units would be from a continuous flow fixture with 0.135 liters per second? Then it's multiplied by 31.7. Now, remember, if it's a semi-continuous flow fixture, we don't use the 31.7, we use the table, 2, 4, 10, 12. So there's the only time that we have to consider them the same is when we're multiplying the liters per second from a semi-continuous and a continuous by 900 to get the liters for a storm and combined system. But they have to be treated separately for fixture units. Okay, yeah, so here are directions. So here we have storm, and here's combined. And then it goes through a couple of examples. Fantastic. Some people are telling me they get questions on this. So remember, it's half of the largest adjoining wall area plus the roof area times the rainfall intensity gets you your liters into the roof drain or the rainwater leader. So with this one, it shows us that because this is 3.6 and 11 meters, that's a smaller wall. This one's larger. Now, the reason why it's only half is because if you think about how rain works, when it's hitting a vertical surface, some of it bounces over the roof line, some of it bounces onto the roof area. It just water just bounces everywhere, right? So that's why, okay, let's be reasonable and say that we only need to account for half of it. Good enough. Gutters. More examples. This one I don't think we need. Okay, rainfall intensities. Where do we get that information? It comes from Appendix C, Division B of the National Building Code. There are tables and tables and tables for multiple cities across Canada, and it has a whole whack of information on there. Rainfall intensities, design temperatures for January, so the coldest weather, and that would be for hydronic heating. They also have wind loads, wind speeds, and that would be for infiltration for hydronic systems. So it all comes off of that Appendix C, all that information for doing all of this work. And remember this, calculating hydraulic load from a roof or paved surface, it should be noted that for 1 millimeter depth on a 1 square meter surface is equivalent to 1 liter. So let's talk about that one because I know there might be some confusion as to why. Okay, so we have a box. This box measures 1 meter by 1 meter by 1 meter. Whoops, 1 meter. Okay. So if we're looking at this box, we have 1 cubic meter, which equals 1,000 liters. Now, what we also know is that measuring 1 meter is equal to 1,000 millimeters. So that's why this is saying 1 millimeter depth. So let's try that out. One millimeter over a 1 meter by 1 meter area equals 1 liter. And that's how that works. All right. Okay, trapping floor drains. What do we need from here? Okay, so this is back to 2511 number 3. We're dealing with emergency floor drains, 3 4-inch emergency floor drains, right? I'm just saying the minimum Trap arm length is 450 on those guys. Everything else is double the size of the pipe. Where I don't need venting. Very often there's a question on this. Where do I not need venting? Remember, there's a picture in the back. Compared to the picture, there's your answer. Okay. Wet venting. I'm not going to go through any of this. This just lines up. Each code clause in the wet venting and circuit venting section has a picture. So if you're confused about what it's talking about, what it's meaning, just come back and look at these. That's all I need to know. Okay, circuit venting, not going to go over any of that. This is going to be a question, most likely. What do I need to install on the branch, on a circuit vented branch, when I have a change in direction of more than 45 degrees? It's an additional. That's what you need to do. If I have more than 8 fixtures located between the circuit and the relief, I also need an additional. Where is it located? Off of the first image that we saw in Division A, between the 5th and the 6th most upstream water closet. Now, remember, on a picture like this, I have 1, 2, 3 toilets. That means this portion of pipe, because everything is symmetrically connected to this point, or maybe on a double Y, let's say, this is 4 inch. 3, 3, 3, 4, right? Now, the other thing too that we should talk about with this is, remember that we're allowed to use a stack as long as it has less than 6 fixture units or less as our relief. But since these pictures say more than 6, that's why we have to have the relief here. Okay, what else? Yoke vents. That's how they're connected. So you're going to get a question on this. What's required if we have fixtures draining from more than 11 stories? We need yoke vents. Now remember, where are they installed? Every 5 stories from the top down. When do we need offset relief vents? Okay, so when an offset is greater than 1.5 meters, it must be sized the same way as a branch or a building drain. An offset relief vent is required at points A, B, or AC in this figure. Okay, so that's what it is. So it says, the stack's horizontal offset is greater than 1.5 meters and receives a discharge of more than 100 fixture units above the offset. Okay, so that's 2 requirements. That's why we have soil or waste stack offsets. That's why we need to know about them, because we may have to install offset relief vents. Now, we have to check both of these boxes. The offset has to be bigger than 1.5, and we have to have more than 100 fixture units above the connection. So if you get a question and it says, on a soil or waste stack offset that is 2 meters long and drains 50 fixture units, do I need to install an offset relief vent? No, because it has to meet the 2 requirements. It has to be more than 100 fixture units, more than 1.5 meters. So it's great that it's 2. I only have 50 draining to it, so I'm good. But remember, because it's 2, I need to size it off the branch table or the sanitary building drain table. Right, so it has to have a grade on it. Okay. Okay. Oil interceptor questions. Always a couple on those. What is the minimum size vent for an oil interceptor? 1.25 inches, right off the picture. What is the height difference? 300 millimeters. Where are the vents located? On opposite ends. What's required in the tank? Well, we need a vent opening between the compartments, so we don't have a vacuum condition happen. What's required downstream? A clean out. Don't worry about this guy. What else do we need from this? I think that's it. So there's quite a few questions on those. Vent pipe connections. Okay, fittings used to connect vent pipes to anomaly horizontal sanitary drainage pipes are specified in subsection 224. And it says, except for wet vents, vent pipes must be connected above the horizontal center line of the pipe. Wet vents, no. All right, here's your picture for determining the length of a trap arm. So remember, it says twice the size of the nominal pipe size of the trap arm fixture drain. Okay, so if this is 1.5 inches, minimum 3 inches. If this is 3, minimum is 6. Maximums, remember, we're going to get off table 2563. That's going to be your maximum. So it's kind of weird. I've always thought it was weird that they threw that in the venting section, but I guess it makes sense. It's saying we can't have a piece of pipe over this length before we have to throw a vent on it. So remember that table. These might be questions. What is the maximum change in direction on a trap arm? So regular fixtures are 135. Toilets, we're allowed to throw an extra 90 on there, so we're allowed 225. This might be a question. What is the maximum trap arm length for a water closet? Answer, 4 meters. 1 vertical, 3 horizontal, 4 total. What does this apply to? Well, it says, the following length and water closet fixture drain applies to floor-mounted and wall-hung water closets. Cool. Vent terminals, this is my favorite. Always a couple questions on this guy. Questions might be, how far from an openable window on an adjacent building does a vent pipe terminal need to be? 3.5. How high above a fresh air intake? 1. How far away? 3.5. How far above an openable window on the same building? 1. How high above the roof line? 6 inches. How high above a roof sun deck? 2 meters. How far from the property line? 1.8. So if you guys remember back to the septic image that I think I've shown some of you guys, all of these numbers are the exact same numbers on the septic drawings. You see that the numbers keep repeating, right? The 30 meters, the 15 meters, the 1.5 meters, the 1 meter, they all keep repeating in every single aspect of plumbing. This 150 millimeters, very, very common numbers. Okay. This guy, if you're ever confused about how to size these things, these vent pipes, go to this picture and there's a table that describes the exact process on how to do it, what you need to include, what you don't, and then a code reference number. Okay, so that's pretty handy. This point here, so sizing relief vents. Length is not taken into consideration when sizing relief vent and an additional circuit vent. Relief vent connected to a circuit vent branch is sized according to sentence 25731 and 2. An offset relief vent is sized according to sentence 25741, which permits the offset relief vent to be one size smaller than the stack vent. That's a question. Well, for some of you. Okay. Lengths to be considered. Another picture, if you want to look at those. This guy, is there anything? Vent pipe lengths to be considered when sizing vent stacks and stack vents are as follows. Okay, so there's another picture showing you how to size those, what the lengths are. You need to add together. Shutoff valves. Multiple risers convey water supply to dwelling units. Each dwelling unit's water distribution system shall be provided with a shutoff valve located immediately where the water piping enters the suite so as to isolate the fixtures as well as the water distribution piping serving the dwelling unit's fixtures. Fixture stopcocks or shutoff valves located immediately adjacent to a fixture may not be adequate to protect the water distribution piping. Where a dwelling unit is served by a single shutoff valve on the water supply, additional shutoff valves may be required to achieve compliance with sentences 2, 6, 1, 3, 4, and 7. Okay, 26165. This one's good too. Flush tank type urinals that are not in use for extended periods of time, such as those in seasonal buildings, are permitted to be set up to flush automatically at predetermined intervals. Automatic flushing prevents the depletion of the water seal due to evaporations or backflow conditions. Trap seal restricts the infiltration of gases, which pose a health and safety concern. Now, one of the questions I've heard lately, and some of you guys have probably seen it, but what needs to be done to winterize the drainage system in a seasonal home or like a vacation home? And the answer for that would be putting plumber's antifreeze in the traps. Now, some of my students have actually told me in the past what they do in situations like that is they just use windshield washing fluid because it's cheap, right? And it can usually handle to like -40. So they just dump that in the P-traps because it's relatively non-toxic. So there's an option. Okay, relief valves. If the discharge piping is longer than 2 meters or more than 2 90-degree elbows are used, the valve manufacturer installation instructions should be followed to ensure the piping does not affect the relief valve discharge capacity. So you may get a question on relief valves. And to be honest, I don't know the answer. I have my best guess. So one of the questions might be, how do you size a relief valve on a boiler, for instance? My best guess is it's either manufacturer's instructions. If that's not an answer, I would go with the minimum of 3/4. And if you do have written answers, what I would also go with is the size of the boiler or the size of the hot water tank would determine the size. So there's 3 potential answers there, and I don't know which one you're going to get. All right. That one. Thermal
What if you got all 3?
What's that?
What if you got all 3 as options?
It's not going to be all 3. It's going to be one or the other. Did you get a question with all 3?
I got a question with 2 out of the 3.
Which 2?
Manufacturer and 3/4.
I would just go manufacturer on that because it may be bigger.
Yeah.
Right. The minimum is 3/4, but manufacturer is going to tell you exactly how big it is. So again, that's my best guess. Service water heaters. Okay, so here's your temperature for water heaters, 60 degrees. What does it prevent? The growth of Legionella. It says the growth of Legionella bacteria is not a concern on other types of water heaters with different designs that use different fuels. So the only place we're really worried about it is electric hot water tanks, is what this is getting at. If it was gas-fired, potentially wouldn't be a problem. Yeah, and that's what it says here, which is not the case for gas or oil-heated water heaters. So just electric. Okay, fire protection. I always keep telling you guys, there are no fire protection questions, but since this is in the book, there might be. A couple of things you might see. Now, the type of backflow device used for fire protection systems, even though I guarantee you we never use them, they have the F on the end, right? So it's an RPF, a dual check for fire protection. Because it's in here, again, good answer. All right. If you ever need to know what hazard class for a fire protection system, which device you have to use, it's right off this table. So technically, it is a fire protection question, but it's also a cross-connection question. Okay. Don't need anything with that. All right, this one, A26261. So when we're dealing with what devices are good for back siphonage and back pressure, we check code clauses 2622 and 2623. Now, if you guys remember, anything that has vacuum breaker in the name is only good for back siphonage, not for back pressure. So I mentioned that a couple times. Now, with this list here, the one you're most likely going to get is this one. There's dock and dockside facilities. What kind of premise isolation do we need for that? Just remember DCVA. Okay, that's the minimum. All of these other ones are RPs. Every single one. Minimum RP. RP, DCVA, RP, RP. Now, the other thing too with this guy here, sewage treatment plants, best RP, but you could also throw an air gap for that guy. Which is why air gaps is right underneath it. Pretty interesting, huh? Huh. Okay, atmospheric vacuum breakers, flood level rim. Don't need any of that. Don't need that. All right. Here's small building method for water pipe sizing. So if you guys haven't gone through that with me yet, you will at some point. Remember with this, the water velocity is based on the manufacturer's recommendations, always. But when you're doing this, remember that for PEX, 3.0 for cold, 2.4 for hot. With copper, 2.4 cold, 1.5 hot. Now, if you guys watch that dude, Mathematic Plumber, don't, because he screws it up every time. All right. So the way he shows you how to do it is you find your governing fixture length, right? So let's say it's 27 meters. So now I'm in 30. And what he shows on the video is you just go straight down and then size it based on going straight down. But that's not the case. You have to use the shaded area that corresponds with the velocity inside of the pipe. So if I'm doing copper cold, 27 meters, 6 fixture units, boom, right there. So we're in the light shaded gray, 6, ½ inch for distribution. Service is 3/4. So that brings up a good point too. What is the minimum size of water service pipe? 3/4. None of these are smaller. Distribution, oh, we're allowed smaller. We're allowed ½ inch or 5/8. What else about these guys? This point here, where the total fixture unit values exceed those given in this table, the system must be designed according to a detailed engineering design method. All right, so what does that mean? Okay, let's say I have, let's say it's cold, copper cold, same example, 2.4. I have 27 meters as my governing fixture length, right? And let's say I have more than 370 fixture units right here. That means that, let's say it said I have 380 fixture units, governing fixture length is 27 meters on copper cold water line. What size? Answer, I can't go beyond this because that shortens the run, right? So I can't go beyond this. So if it says 380, detailed engineering design method is your answer. So that's how that works. Okay. Oh, one more thing about that. On your test, if you forget and you're not sure whether to use 3.0 or 2.4 as a velocity, let's say, it doesn't matter, because if you use either one, you come up with the same answer. So don't stress out about it if you get a written question like that. Hey, service. Okay, here we have the average pressure loss method. Here is your table if you have to do this kind of math on your test. Now, sometimes people get confused with this one down here. It says the average pressure loss must be a minimum of 2.6 kPa per meter. Okay, so what if it's less? Well, if it's less, we can't use the average pressure loss method, right? We'd have to use this one. Okay, small building. So if it's less than 2.6, can't use that method. You have to go back to small building to do it. All right, what else? Average pressure loss method. Again, walks you through exactly how to do it. Oh, and the other point I wanted to make about this one, where is it? This always confused me for some reason. So to calculate the total equivalent length for the water distribution system, determine the developed length from the water service entry point to the building to the most remote water outlet. And where the fitting inside diameter dimensions are at least equal to the NPS, multiply the developed length by 1.5 to allow for friction losses. And where insert fittings are used, apply additional losses in accordance with the fittings manufacturer's data. So what these are talking about is we know that copper fittings, the copper pipe fits into the copper fittings, and then we solder or braze it, right? Or use compression or whatever else. But with PEX, the fitting actually fits into the pipe. Okay, so that's what it's trying to get at. It depends on what type of pipe we're using, where we have to have this 1.5 meter or 1.5 times the governing fixture length. Now, what I've been told over the years is if you're doing the average pressure loss method, multiply it by 1.5 anyway. Okay, but I'll leave that up to you guys to decide what you want to do if you get something like that.
Wait, like multiply, when do you multiply it by 1.5?
The governing fixture length. So let's say we're using the example of 27 meters. I would multiply that by 1.5 to be able to use the tables.
Oh, okay.
Okay. Now, this book does some really strange shit right in here. Right. So what they did, they have a number of fixture units, right? And it makes sense, you know, liters or meters per second on all of them. They put in 1.2, which I'm assuming is for hydronic heating. It's the only thing I can figure out or guess. All right. What else do we need from this? Nothing there. Nothing there. Okay, sizing for flush valves, distribution piping, water mains, serving flush valves may be sized using the valves assigned to tables 26, 32B, and C, beginning with the most remote flush valve on each section of the distribution piping served by the water main. So when we start those fixture unit calculations for a bank of direct flush valve toilets, we always start with the furthest as the highest fixture unit load and work our way back to the supply. Then we have our simplified method. Remember that this is only for single family duplexes or townhomes with separate water services. Okay, so there's a couple of things in there. We've seen that many times throughout the code book, single family duplexes, townhomes. But it says with separate water services. So remember back to that first image, if we're running the same water services, we can't use the simplified method, even if it's a duplex or a townhome. Okay, we have to use the other method, the first method. Okay. Now, the other thing too that's important about this is if there's any other building attached to the water service line feeding a single family, a duplex, or townhomes, we have to use the first method. Okay, we can't use this. So you might get a drawing or you might get information. Let's say we have a duplex, which is fed by the water distribution line. But attached to that, we have like a common laundry room or something like that. That means because of that extra building attached to that water line, we cannot use this method to size that pipe. All right. Anything extra? No. But when we're doing it, design must ensure that the minimum static pressure of 200 kPa is available at the water service entry to the building. So the minimum is 200. And the total developed length of the property line to the most remote fixture is not more than 90 meters. Okay. Now you guys know the questions you guys see, and it's going to be water main pressure is 800 kPa. What is done to reduce the pressure to, or what is done to reduce the pressure to a fixture? And that would be turn it, I believe, counterclockwise down to 550 max. Something's there. A couple pictures. Something I do want to show with this. Okay, so water pipe, water distribution piping. Now, in the DWV table 2493, and if we look at the potable water line table 2632A, it does mention bathroom groups in both. Okay. Now, the reason why it does is because one person can't physically use all three fixtures at the same time. Well, I guess you could, but it'd be a complete waste of water, right? So what they allow you to do, if we have that bathroom group, is, let's say, what's the worst case scenario? Let's say you start filling up a bathtub and you go and take a shit before you have a bath, right? So you flush a toilet. That's the worst, because the toilet has 2.2 fixture units and the bathtub is 1.4. Add those together, that's your 3.6. That is the worst case scenario. That's why they tell you it's 3.6 for the bathroom group on the water lines. Now, if, again, we have any other fixture connected to that piping, like the clothes washer here, and here we have a kitchen sink on the opposite side, well, now we have to add all of these up separately. So it would be 1.4, 1.4, 0.7, 2.2. That gets us 5.7. Same with this. 0.7, 1.4, 1.4, 2.2, 5.7. So if there's any other fixture connected to it, we can't use bathroom group. Now let's give you another scenario. Okay, so let's say we go down here, and you have to do red, sure. Let's say I run a clothes washer to right there. At this point here, I can still use bathroom group 3.6, no problem, because it's before the bathroom group. As soon as I get to this point here, now I have to add the clothes washer in, so that maybe it's 1.4. So now this would be 5 fixture units there. All right. Let's say I add a kitchen sink over here for whatever reason. Now I've got 0.7, 1.4, 1.4, 2.2, 1.4. So now I just add 1.4 to this, would be 7.1. It's exactly that easy. So use the pictures in the back to help you guys out. All right. Now, this is where they do something really strange. I don't know why, but they put the fixture units on this side and then they size it for each of the water velocities. I don't know. I guess because they don't really specify what the velocities are. Could be. Okay. Non-potable water system design. There's a growing interest in Canada in using available non-potable water supplies in the place of potable ones for selected purposes such as flushing water closets and irrigating lawns and gardens. Article 2711 applies to non-potable water systems regardless of the origin of the water. The non-potable water must meet the applicable water quality standards as determined by the authority having jurisdiction. So they're the ones who tell you, but in the same respect, we're allowed to use it for toilets. We're allowed to use it for irrigation. Okay, this is important too. Above ground roof surfaces, where it's possible to harvest rainwater from surfaces other than above ground roofs, such as patios, lawns, gardens, driveways, roadways, parking garages, and parking lots. These surfaces are not suitable catchments for rainwater harvesting systems because the water quality concerns. Water collected from such surfaces may be contaminated with fertilizer, herbicides, fecal matter, garbage, oil, or chemicals. Now, that fecal matter they're talking about could be bird shit. It could be any kind of animal. Squirrels, rats, whatever. What else do we got here? Okay, 27221. Okay, it's treatment for use. So harvested rainwater used in any permitted application must be treated appropriately for its intended end use. Pedestrian traffic. The prohibition of pedestrian traffic on roof surfaces stated in sentence 27231 is not intended to include access to roof surfaces by service personnel, such as window washers or HVAC mechanics. Now, I don't know that you guys have all of these code clauses in your 2015 if you're using that, but still a good idea to go through it. One question in particular with non-potable, I think I've talked about it before, but mention it anyway, is anything that's non-potable is going to be identified with something purple, right? So whether it's purple banding, purple insulation, purple writing, purple pipe, it's something purple is non-potable. So rainwater, technically considered non-potable. Okay. And anything in here? Nope. Nope. There is one more thing I want to show you guys. And this, I don't think we need any of that. Index. I mean, if you guys use this, great. But for the most part, I don't really find it too valuable. More of knowing where to look is probably a better idea. Knowing what section to look in. But might help you guys. I don't know. All right. Very last page of the book. Has common abbreviations. So if you're ever in doubt as to what something's called, it's right there. These ones are key because they give them to you. They can technically ask you about it. So let's say I have a question that says I have a continuous flow fixture that discharges, I don't know, 50 GPM. How many fixture units would that equal? Okay, there's a couple things you got to do. So it says right here, so we'll look at this, to convert liters per second to GPM, 13.2. What we want to do is we want to go the opposite way. So from here to here, multiply. So these are all, so this times that equals, whatever it is that way, right? So because we're going the other way, we want to divide. So you can say this way, multiply, and this way, divide. Okay, so we take our 50 GPM divided by 13.20. And what did we get? 50 divided by 13.2. That equals 3.79 liters per second. Now, because I know it's a continuous flow, I can now multiply that by 31.7, and that gets me my fixture units, which is 120. That's a lot. But that's how you do it. Okay? With the numbers in the back. Now, the other thing you can do, so we're going to talk about math a little bit here, but we know that the number we use is 0.433 or 434 PSI per foot when calculating pressure. Okay. The other number we use is 2.31 feet per PSI. Okay. How do we get those numbers? Well, it's very simple. 1 divided by that equals that. 1 divided by 2.31 feet per PSI equals 0.433 PSI per foot. Okay. So having known that, if you only know one of the numbers, you can get the other number just by doing 1 divided by that. That would also apply to U and R values. Okay, for heat loss calculations. So any of these numbers over here, you can do the opposite. So let's say we want APA to PSI. Oh, well, I've never seen that 0.145 number. Well, let's see if we do this. Let's go 1 divided by 0.145. What does that give us? 6.896, close enough, kPa per PSI. Okay, so we can get the other numbers if we want to, right off the numbers in the back. Pretty fun. That is it. I think we're done.